Amperage. Move the function selector to the amp setting, marked by the A. Start with the 10 amp setting to reduce the chance of overload. If you know the amperage will be less than 400 milliamps, you can select the milliamp setting. The setting defaults to DC amps. To measure AC amps, press the mode button once. Now move the red Load Pro lead to the left upper port marked 10 amps. To read on the milliamp scale, move the lead to the milliamp port.
So that means if I go to amps, I should very confidently be able to go to amps and jump from here to here, and it cranks the engine.
If you read voltage with the red lead in either of the two amperage ports, you will blow the meter fuse, but you will not damage the meter. The series ammeter is a jumper wire, so when the ammeter is used, special care must be exercised to make sure no one can be injured if a component operates. This is also why you must never use the ammeter unless you are 100% certain of where you are in the circuit. The two ammeter ports are fused at 10 amps and 400 milliamps to avoid overloading the meter circuitry. The ammeter reads in microamp, milliamp, and amp units.
The amp meter is the least understood function in this meter, and it's a really neat meter to use if you use it safely. Here's the first thing I'm going to tell you about the amp meter. Some people call it an amp meter, some people call it an amp meter. It's the same difference, it doesn't matter. This is called a series amp meter because you actually use this set of leads to complete the circuit. The amp meter is dangerous to other people, not to the meter, because the amp meter is fused. Right here, these two ports are fused. So if you accidentally hook the meter in wrong, there's a really good chance that these fuses will blow and the meter will not be damaged. All that has to happen then is you have to take the meter back off and change the fuses, which can be tedious, but that's just the way it is. I have an entire bag full of fuses in my toolbox because you blow them. It just happens as part of the deal. So why does that happen? It's easy. As soon as you move this lead here to here, this meter is now a jumper wire. That 4-foot piece of primary wire that you pull off the wall, here it is. This is the exact same thing as that 4-foot piece of primary wire that you pulled off the wall, except it's longer and it's fused. So you've had a jumper wire in your meter all this time, and most people didn't know it. The reason you have to be careful is because if you see a number on this meter, it means something is happening. If something's happening, somebody could be in the way of that something happening. And I've worked and taught at some places where machinery is huge, and there's the lockout tagout rule, and the amp meter could play into the lockout tagout. It's not a meter that you just go in willy-nilly and just use, okay? The voltmeter, fine, no problem. Ohm meter requires a little bit of thinking. The amp meter requires a pretty good amount of setup, because what you don't want to do is go in, jump across a switch, turn on a solenoid, have the accumulator discharge and move a bucket or move a blade or a crane and hurt you, hurt someone else, or hurt the machinery or hurt the shop, okay? So don't be afraid of the amp meter, just be aware of what it is. Use the same caution using the amp meter as you would using a straight old, just a plain old piece of wire. The best place to use it is across the open switch. So if you are wanting to know whether the circuit's working and you're thinking, well, maybe the switch is bad. Well, first of all, you shouldn't be asking maybe the switch is bad. You ought to just be testing. But if you want to test and say, well, gee, I wonder if the switch is bad, and you just want to jump across it, go ahead, okay? Use the amp meter. It's right there. It's a lot safer, it's easier, it's fused. If you make a mistake, you don't hurt anything. You just blow a fuse. So the amp meter is a very useful tool, but you have to be cautious, because if you see a number on the screen, then it means that current is flowing, and if current's flowing, something's happening. And on some of the stuff that you guys work on, that something could be very big and very deadly. Don't be afraid of the meter, but be afraid of the outcome if you don't use the meter with caution. The top port is for high amperage, the low port is for low amperage. The meter reads in amps, milliamps, and microamps. You'll use the 10 amp scale probably more than any other. It reads and gives you some milliamp reading, but it's not as accurate. So if you need a more accurate answer and you know that your current flow is below 400 milliamps or 0.4 amps, then move the red lead from the 10 amp scale down to the 400 milliamp scale and put it in there. And then you move the meter here to 10 or milliamps or microamps. Microamps is millions. Quite frankly, you won't be using it very much. You could, especially on sensors, but probably not, okay? But if you do, it's there, and you need to be in the lower port. And remember that you still only have 400 milliamps to work with. 10 amps to work with here, 400 milliamps here, okay? So be very cautious. You don't ever push the load pro button on amps. It doesn't do anything for you, and it's just gonna mess up the reading. Otherwise, it's just a set of leads, okay? So just don't push the button on it. The amp meter is a good tool, okay? It's a safe tool if used properly, and there's no reason for you to be afraid of it. Just don't hook it across the battery. If you hook it straight across the battery, you just blew your fuse, okay? So be very careful when you have it on the amp setting that you're in some place where you know you are, and make sure that you know exactly where you are and you know exactly what's gonna happen. The voltmeter, you can just go blah, 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 poke, 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 you know, test, test, test. That's fine. Amp meter, not so much, okay? So use it, be aware of it, but don't be afraid of it. And if you become comfortable with it, it could be a very valuable addition to your electrical tool bag. Well, that tells me that this terminal is going to ground. And since I know how a relay works, there's the switch, I had voltage here, so this has to go to the clutch. So that means 87 is touching the clutch. Right now, this wire at this terminal is going through this harness somewhere and ending up in there in the engine compartment of the clutch. Well, I can prove it by simply reading the voltage. Excuse me, by reading resistance. I know this goes to ground through the clutch, so I simply read it and I get 4 ohms. And 4 ohms is pretty normal, okay, for a clutch and for other larger components like that. So I'm actually measuring the resistance of the clutch from the relay. So I'm actually measuring the resistance of the clutch from the relay. You need to learn how to do that, because if you know how a relay works, you understand that every part of the system comes to this 1 square inch. So you have access to the coil and the clutch in this 1 square inch, and you need to know how to do this. So I got voltage here and I got resistance here if I care, and that means that if I jump from here to here, I should make the clutch work. Well, let's try it. Put it on amps. Put it on 10 amps, move it to the 10 amp setting, and now I'm going to jump from 30 to 87, and I actually expect 3 amps. And the reason I expect 3 amps is because the 12.45 volts divided by the 4 ohms gives me 3 amps. And sure enough, 3.09 amps, and I heard the AC clutch kick in. So I am using my meter on amps as a jumper wire, and that jumper wire is allowing me to confirm that the clutch is working. So if you thought the clutch wasn't working, if you knew this was the relay, you could come test the entire system right here. So let me go through that again for you, all right? And by the way, remember to move your red lead back when you're finished with amps. Volts. Ghost in 0 voltage. That's a short to ground. That's open. I go into 30, system voltage, immediately load the circuit. Voltage doesn't change. The wire coming to terminal 30 is fine back to the battery. I go to ground through the clutch. I see I have continuity. I confirm that's what it is. I move to ohms. I expect a fairly low number, and sure enough, I get 4 ohms. Okay? So now, if you care, you can do the math, and 12 divided by 4 is 3. So now I go to amps, and I jump from 30 to 87, and the AC clutch kicks in, and my calculation of 3 amps is correct, because 12 volts divided by 4 ohms is 3. Volts over ohms equals amps. Volts and ohms make amps.